Hi guys, good to see you back. I hope everybody's feeling really rested after spring break. I know I am. That last week before the break was pretty hectic, but it appears as though that's going to be our reality for the next little while. So let's just make the best of it. I know you guys have a lot of questions, and I also have a lot of questions. I have not heard a lot from Mr. Stevenson about what's going to be expected of everybody in the next little while, but as I do hear, I'm going to make sure that I keep letting you guys know, so just make sure that you're checking in every single day, and I'll do my best here. As far as what to do with the integers work that lots of you are looking on Jupiter grades and seeing as being incomplete, I want you to hang on to it for now. I'm trying to come up with a way that you're going to be able to hand stuff in, but for now, just hang on to it. It's not counting against you. It's just a blank spot on Jupiter grades. Okay, so relax. As far as getting new material out to you, that again, I'm trying to figure out how that's going to happen. Hopefully I'll know that later on this week. But we are going to continue on where we left off last week with linear relations. So I filmed this video that you're going to see right now a little bit earlier on in the week. And let's watch it. And please, I ask you guys, please try to watch every single one of the videos and follow the instructions. It's really difficult to deal with your questions that were answered in the videos. So if you have questions about content, that's fantastic. Keep those ones coming, but please watch the video first and follow along. Do the worksheets as you were asked, submit them as you were asked. I think I've been pretty clear with my instructions, but those of you who don't watch the videos and just do the worksheets are making errors because of that. So let's just try really hard to follow the instructions and do what I ask of you. It makes it easier for you, makes it easier for me. This is reality for now. So let's just do our best. All right, so we're going to take a look now at how to put everything together when we've got a diagram here. So it gives us the number of squares, and then we look at perimeter. And if we remember back to our area and perimeter unit, we know that perimeter is the distance around the outside. So I look here, if I have one square, the distance around the outside is 4. 2 squares, the distance around the outside is 1, 2, 3, 4, 5, 6. So with 3 squares, if I count them up, I'm going to see that there's 8. And if I look at 4 squares, I will see that there are 10. Great. So the next thing that we want to do is try and draw a graph. So this should be pretty easy, right? I'm going to give my graph a title, and I'm going to call it perimeter. Because I know that it is very important to always give your graph a title. So I'm now going to label my 2 axes. I've got S and I've got P. So this one is going to be number of squares. And this is perimeter. All right, so now it's time to start numbering the intervals here. So I'm going to have 1, 2, 3. Geez, it should be safe in your own home. Enough! It's target practice. All right, so now I'm just going to go 4, 6, 8, 10. So hopefully, when you guys were doing this, you looked and you went, wait a minute, that's not right. Something's wrong with the way I've labeled these. And the reason something is wrong is because I don't have a 2 here. And I have to make sure that my intervals are consistent. So I'm going to go 2, 4, 6, 8, 10. All right, and my first point is going to be at 1, 4. Then I've got one at 2, 6, 3, 8, and 4, 10. So what I have here is a linear relation because the points are in a straight line. Now, early on in the unit, there were some people asked me, is there always going to be a point at 0? Well, if I put a point at 0, what happens here is it's no longer linear. So the answer is no, I can't have a point at 0, 0. That would not be correct in this case. So now we've got to think about describing a pattern. Well, the pattern would be that for every horizontal increase of 1, meaning adding one figure, we are adding 2 sides. So now we've got to try and figure how we are getting from here to here. If we're going to come up with an expression, we've got to figure out how we're getting from one to the other. Well, I know that we're starting with these 2 sides. These are what we call a constant because they remain constant the entire time. So I'm going to add those to something else. Well, what am I doing with the squares each time? It looks like they're doubling. So I'm going to take 2s plus 2, and we're going to just check and see if this works every time. So if I take 2 plus 2s, well, what is 2 times 4? Scott, or sorry, 2 times 1, Scott, you know what that is?
2 times 1 equals 2.
Good. And
Can I show you?
And then I add 2 more, and it gives me 4. Scott, what is 2 times 2?
2 times 2 is 4.
Plus 2 is 6. Scott, what's 2 times 3?
2 times 3. 2 times 3 is 6.
Is 6. So 6 plus 2 is 8, so we know that we have figured out the expression. I am not going to put an equal sign here because we were asked for an expression, not an equation. Well, the last piece here, it says, well, what if there were 50 squares? All right, so all I'm going to do is I'm going to substitute in 50 right here. Mark, what's 2 times 50?
100!
100 plus 2 is 102. Thank you. So in your last homework assignment, you had a similar question to this about the community center costing $5 per person. The difference with this question is no matter how many people you have, the community center is charging you $50 to rent the place, and then on top of that, $5 per person. So we want to know here how much it will cost if you have 20, 40, 60, or 80 people at your gathering. All right, so I know that it's $20 a person. How much is 20 times 5? Yes?
100.
100. 20 times 5 is 100. But I can't forget that I also have that $50, so I've got $150. Now, if I have 40 people, do I just double it? Let's see. Do I just double it? Thanks.
Oh, come on, I tried to hit her.
I'm not going to just double it. Let's see what happens. So if I take $40 times 40 people times $5 per person, how much is 40 times 5?
150, Mrs. Maskew.
40 times 5 is 150. Are you sure?
It's 200.
200 plus another $50 is $250.
50.
Well, that's interesting. The number of people doubled, but it cost it. Well, let's try 60 people. What is 60 times 5?
300.
300 plus another 50 is 350. Okay, we're starting to see a pattern happen here. Well, what if we have 80 people? How much is it going to be if we have 80 people?
400, Mrs. Maskew.
$400 plus that $50 to rent the building is $450. Well, time to put this on the graph. I'm hoping that nobody graphed it 150, 250, 350, 450. Because if we did that, we didn't pay attention to all the intervals having to be the same. So let's go up by hundreds. So let's go 100, 200, 300, 400, and 500. So if I have 20 people, it's going to be 150, 40 people is 250. Oops, I put that in the wrong place. 40 is over here. 60 people would be 350. And 80 people would be 450. Is this a linear relation? Absolutely, it's going up in a straight line. So now we've got to come up with an expression again. An expression does not have an equal sign. So I know that I'm going to take the number of people multiplied by what? By 5. Then I'm going to add that $50. So 5 times the number of people plus $50. Perfect. Well, let's see. Could I have points between the ones on the graph? Well, let's see. Could I have a party with 50 people? I don't know. Let's give it a try. So $5 times 50. What is 5 times 50?
2,500.
How about 250 plus another 50 would give us $300 for 50 people at our party. Well, you know, I really miss some of you guys, so I figured I'd try and throw some of your names in the questions, and this question is for Danielle. So I don't know if Danielle likes snowboarding. Maybe she does, who knows, maybe she hasn't tried it, maybe next year. So we've got Danielle here who's going to rent some snowboard equipment. And she knows that it costs $40 for the first day to rent snowboard equipment, and then it costs $35 a day after that. So the first day is the most expensive. So if we go for 1 day of snowboarding, it's $40. 2 days is $40 plus $35, which is $75. So if we go for 3 days, we're going to add another $35, which is going to bring us to $110. And if I go for 4 days, that's a whole lot of snowboarding. I know my legs would be real sore, but I'm going to add another $35, which brings us to $145. Well, maybe we want to go on a real long trip, so we got to figure out how to come up with an expression. Well, I know that it costs $35 per day plus, how much extra did it cost the first day?
$5.
It cost an extra $5. So $35 times the number of days plus $5 for the first day will work each time. Now at the bottom, the last question asked you, if it costs $350 to buy the equipment, at what point is she better off just buying it than renting it? Well, if I add $350 to here, I can look and easily say that if we go for 10 days, 35 times 10, that would be $350 plus $5 would already put us over $350. So the maximum number of days we could go would be 9. The 10th day would mean that it would make more sense to buy the snowboard equipment. Good. And we're back with the last practice question here with Venice and her back to school party that she's going to be planning for us. Isn't that nice of Venice? Thank you, Venice. You seem like you'd be a great party planner. All right, so we know that it's going to cost $8 per person plus $24 for a cake, no matter how many people are there. So 24 is what we call a constant. So I'm going to have 24, and I'm going to add it to no matter how many guests we have. Well, I know that it's $8 per guest, so I'm going to represent that as 8G. So 8 times the number of guests plus $24 is going to give us our answer. Well, could we have 0 guests? Well, that wouldn't be much of a party.
Oh, yeah.
I know Venice is going to plan a great party for us, so we're not going to have a 0 here. I also know she's not going to be alone, but, you know, we got to start with 1. So 8 times 1 is 8, plus 24 is 32. So it would be $32 to have 1 person at the party. Well, if we want to have 2, we now have 8 times 2 is
16.
Plus 24 is 40. What about if we had 3 guests? Well, 8 times 3 is
48.
24 plus the other 24 would be 48. But we're not going to have 3 guests because we want to have a full class there. So let's imagine that our full class was 23 people. So I'm going to now have 23 times 8 is, oh, this party's getting expensive. $184 plus 24 is $208 for a party that has 23 people. That's enough for today. Make sure you check back tomorrow. I'm not going to put out a video tomorrow. I'm going to have a PowerPoint for you that's going to explain exactly what I want you to do. So bye for now.